Before we can start to analyze circuits in a mathematical fashion, we have to understand the concept of equivalent resistance. An equivalent resistance is essentially the total resistance of an entire circuit. So if the voltage source, such as the battery, needs to drive current through a certain number of resistors, there's a total resistance that we can assign to the entire circuit that will dictate the total amount of current that comes out of the battery or the voltage source based on however we set these things up, whether it's in series or parallel, etc. So first things first, we just want to realize that when we have one resistor, the resistance or the equivalent resistance is literally just that resistor. It's only one, so that is the resistance of the whole circuit. If I add two of them, however, I now have two things in the way that these objects have to go to. And if I add a third one, again, we're adding more obstructions in the same pathway. Therefore, we realize the resistance increases. We touched upon this in an earlier video when we talked about adding toll booth stations in series, one right after the other. The more and more resistors you add in series, because the electron has to go through every resistor, the resistance therefore increases. So if you'd like to find the total resistance or the equivalent resistance in series, it's very straightforward. You just add all your resistors together. R1 plus R2 plus R3 plus, if you have more, you add more as well. Where RT is the total or equivalent resistance in ohms, and R1, R2, R3, and so on are just the first, second, third resistor, and so on. If you want to analyze a series circuit mathematically, you want to follow the four steps shown here. Calculate the total resistance or equivalent resistance to begin with. Determine the total current coming out of the battery based on that total resistance. Apply that current to all resistors in this circuit if it's a series circuit, because the current must always be the same in a series circuit as there's only one pathway. And finally, once you have that information, we can calculate the remaining, the voltage drop, the power for each resistor, and it's fairly straightforward to do that. So we'll look at an example in the next couple of videos, and you guys can see how we apply these four concepts to those situations.